Hello everyone. Welcome to the second part of this recording of building a machine learning product which can recognize the profession of the person in the image. In the previous recording, we have seen on a local machine how we can build this particular application, right? We built a Flask application which has a bunch of HTML files, it has a bunch of CSS files, and it has the Python script, right? That based on the endpoint that you are providing in your HTML page, it executes corresponding code in the backend, right? So if you guys remember, we passed an image and then we had the model make the prediction on whether the person in that image belongs to a particular profession or not. And then we also asked the end user to give feedback to the model, right? So it basically tell the actual image, the actual profession to which that particular image belongs to, and then make sure that the model, it gets uploaded in the training data. Right? So that once in a while, if you run the collaboratory notebook, you'll keep on training the data with training the model with new data. Right? So now what we're going to see is, that is all good. But what we're going to see now is the fourth step. If you guys remember, let me just open up the previous canvas. Right, if you guys remember, this was the discussion that we had in the last recording, right? We looked at the first 3 steps along with the 5th step, but 4th step is the step where we are trying to deploy an application to Google Cloud, Google App Engine. Right, we took the first step, we built a image detection model, we wrote Python code snippet, we created the necessary HTML files, built the Flask application, and we also saw end-to-end how we can take feedback. Everything, the first, second, third, and 5th steps in a local machine. Now comes the 4th step, right? Deploying the Flask application in Google App Engine. That's exactly what we are going to see. These are the steps that we're going to use to do this. First, we create a project in Google Cloud, and then we create something called a service account, and then we're going to download the access key. I'm going to explain what a service account is and how we download the access key. And then you create the app.yaml file and requirements.txt. I'll also explain what these files are. And finally, we're going to deploy the application live, and then we're going to see how it is going to work. Okay, so now let me go to the console, Google Cloud Console. So this is a console, right? console.cloud.google.com. You get the Google Cloud Console, and there I'm logging in with my user account. Right, so you guys are clear what we're trying to do now here, right? So right now we have Eagle Eye, the folder in my local machine. Now I'm going to deploy all these folders, all these files and this folder onto Google Cloud. Right, so here I have templates. Under the templates folder, as we discussed, I keep all the HTML files, and in the static folder, I have CSS and images. I'm not using any explicit CSS here. I'm just using the CSS that is directly available from Bootstrap. If I want to keep any images, I keep the images here. Okay, now let us come to Google Cloud Console. So I just need to log in with my account. Let me just switch to my Apex account. The Google Cloud Platform, as you can see here, this is how it is going to look like. Okay, so and first things first, what you need to do is you need to create your own project. So these are all the projects that I have. Okay, first let me also show you how the project is created. So create a new project. Click on new project and give a good name that explains what you're trying to do. There's something like profession prof detect, that profession detection, right? So this is the project ID that we're going to use, right? And this is the organization name, which I'm already part of this organization, right? So I just have the organization name, and I can at the max create 30 projects. So depending on the account that you have, if you have standalone account or you have using your own organization account, you can set the quota, right? Click on create. Right, now it is trying to create a project, right? Now if I go to, it's still in the process of creation, right? So that's the message that you get, right? The project is getting created. I will just wait for the project to be created, but the project that we are going to see in today's demo is my project, which is Eagle Eye. That's the name of the project that I created. Right, now this is here, prof detect. If you click on prof detect, right? As you can see here, I'm in the storage section, right? So how do I know? Here I go to click on navigation menu. I can see all these things that are available, right? I'm not going to explain everything that is here. We're going to see only those things that are necessary for us, right? But the first thing that we're going to look at is something called security. I am an admin, right? If I go to I am an admin, here it shows all the identity access management concepts. right? This says these are the members who are part of this project. If you want multiple people to collaborate, which I feel you should strongly do, right? Because you are all part of this batch, isn't it? So form teams and try to collaborate on it, because together, if you're learning, you'll be learning faster, right? You can also assign the roles, members and roles. I'm the owner right now, but I can be assign more roles also, right? Now, the most important thing is I need to create a service account, right? So why do you need a service account? The service account, what it does is this. As you can see here, a service account represents a Google Cloud Service identity, such as code running on compute engine VMs, apps, app engine system running outside Google. So basically, you need service account, okay, to represent services, rather than always running a program based on whether the end user is accessing that running the program or not. So basically, if I don't create a service account, what happens is every time I run a program on Google Cloud, it will always ask me for my authentication. That is painful, isn't it? Who wants to always keep putting the token or always type in his username and password every time he's running a program? You don't. Rather than that, create a service account, right? This account is only for deploying this Eagle Eye application on the cloud, right? Whatever Python Flask application that you're deploying on the cloud, you tie that to a service account, run a service, right? That's exactly what we're going to do. We're going to create a service account for the service that you're going to write, right? So here I'm going to say the service account for this particular project is prof detect, right? And this is the service account ID that automatically it provides, profdetect.im.gserviceaccount.com. So maybe if you want to separate between the project name and the service account name, keep something like this: image recognition, right? That's the service account. And you can also describe that this service account deals with creation, deals with accessing the image recognition service that is part of the Flask application deploy. Right? Now I click on create, right? And then it will ask you to grant this service account access to a project, the service account permissions. First, I'm here looking at the permissions that this service account has, right? Can it be the owner? It can, right? So this particular service account can, for the project, right? I can just make it owner. This will have ultimate permissions. Every permission, it can create content, it can store data in cloud storage buckets, it can pretty much do everything, right? This is a super admin kind of permission. Otherwise, I can just give it access approvals, right? Android management user, app engine admin. So this is what I want my service account to have: app engine admin, right? Full management of app engines, but not storage. It's just app engine, right? App engine service admin helps you to view and change traffic splits and delete old versions, can create new versions, right? Again, AutoML, right? And then BigQuery, right? So all the different Google services that you have, billing, cloud storage, that's a big one, right? That is going to come. Cloud SQL, as you can see here, SQL admin, SQL client, right? So what are all the things that you want to do with the service account? You can mention that here, right? Stackdriver profile. Stackdriver is nothing but a tool that is used to debug your code once it's deployed in Google Cloud Engine, right? So right now, I'm just showing you for demonstration purpose. I'll show you what are all the permissions that my service account has, Eagle Eye. But this is how you create your own service accounts, right? Just click on continue. And then who are those users to which this service account role is actually given, right? Grant access to user groups that need to perform actions as so on your behalf, right? So basically, I give my name first here, right? Sai Charantaj and any other people. So basically, service account is your proxy. Instead of you, Google trying to authenticate you, what Google will do is Google authenticate the service account directly so that you can directly connect to the application, right? And then this is something that you need to do: create a key, right? Create a key, and it's a JSON file format. Yes, create it, right? And this is how it is already downloaded. By default, it's downloaded. Prop detect PC forward JSON. I'll show you where that is actually used, right? Click on done. So you have created the service account. Okay, this is the second step, as you can see. Right, we created a project and we download the access key for the service account. Right, now for the third and fourth steps, I'm going to switch to my project, Eagle Eye. I've used the free credits, by the way, 30,000, 21,000 free credits. I've already exhausted 6,000. Right, I created different service accounts, but this is a service account that I used. Okay, I just click on the service account. This is the Eagle Eye. The name of the service account is this. This is the key ID, right? And then it has also the description, right? I can also delete this service account, edit it, create key, show client ID, right? And these are all the permissions. Let's say, for example, if I click on this, right, and then here I can see all the permissions that are assigned to this. I gave even more options because I was trying to experiment with all different combinations, access permissions, privileges, everything, right? And this is how it is going to look like. Right, as you can see here, I gave one privilege to these two users. Okay, now let us get to the application. Right, in order to go to that code, right, where you want to deploy your code in the local machine, in order to deploy that here, what I'm going to do is I'm going to activate something called Cloud Shell. Click on Activate Cloud Shell. It is going to show up here, but I want this in a bigger screen, in a larger screen, so that I can perform all the actions that I wanted to perform. Right, so that's the reason why I'm just opening this in a new window here. Okay, and this is the default shell. This is the interface using which you can programmatically tell Google Cloud as to what to do with your code, right? So I just use LS7LRT. This is a command that here you need to create your own directory. I created my own directory called env. Right? Env is a directory in which I keep all my code, right? So LS7LRT. This is all the code, right? It has the lib module. It has the templates folder. Right? I just copied all the code from local machine here. If you go to lib, right, these are all the libraries that I needed for deploying the code, right? Python 3.5, right? There is also other codes, other libraries that are used that might be useful, right? Some of them come by default, some of them I intentionally install, right? So all the necessary libraries you keep here, right? Even if you don't keep them here, they'll automatically get installed. I'll explain how that is. Okay, and if I just come back, right, you see that we have this credentials from Google app.json. This is the JSON file that you just downloaded. Right, this is the file that I'm going. This is the JSON file that talks about my service account, my Eagle Eye service account. Okay, and this main.py. Any guesses as to what this Python file is? There's nothing but your Jupyter code. I just downloaded as a .py file. I downloaded my Jupyter Notebook code as a .py file, and then I uploaded that .py file here. So if you see here, this is the exact same code that we have seen. Uploading image, right? The service endpoints are the same: update, train, classify, right? Upload, and slash. Right? So that's the next step. Next step is you copying all these files, and now you need to tell Google Cloud as to how exactly it should deploy this application. Right? For that, there are a couple of files called cat app.yml. Right? So this app.yml file, that is the third step here, isn't it? Create the app.yml file and requirements.txt. App.yml file contains the runtime environment of Python. Right? It has runtime configuration of Python. All the environment variables. I was initially using a cloud storage bucket. Right? That storage bucket information is also present here. And it also says script equal to main.app. Right? URL is static. Right? So basic information that you generally find in any .aml file. I'm just creating my app specific information, storing that here in this app.yml file. This tells Python that, this tells Google that it's a Python program that is going to run. Okay, and the next one is cat requirements.txt. If you see, this contains the names of all the packages that I was using in my code, in my Jupyter Notebook. right? All the packages I directly imported here. In my local machine, I use PIP to install them, right? But how do you tell Google Cloud to install the exact same thing, right? That's what I'm doing here. So what I'm doing here is I'm telling the names of this particular application. You see here, this is image.io, right? It's a WHL file, image.io package that contains RESTnet algorithm. Right? It's a WHL file, right? So I just gave that entire URL here, right? Cat requirements.txt. This file has to be present in this particular manner, okay? And the directory structure has to be maintained this. I manually create all these files, right? But you can use different tools to upload these files directly from your from your desktop. That you have Putty, you have different file transfer clients, right? You can just upload the files and they can directly be downloaded here. You can also do it because it's just nothing but a shell that you're looking at here. Okay, so now these are the steps that make up the creation or the setting up of your environment. Okay, and now you also see that model class.json, train model.h5. These all comments are important for you to look at this file. Now, before we deploy the application, let us also look at the code in a bit more detail. In the previous class, we briefly touched upon it. Right? Till here, it is fairly straightforward. Right? You looking at home, render template, right? About, upload, everything is fairly straightforward. Even prediction is also straightforward, right? We are loading the number of, we're loading the model, and we're making predictions. Among the top 3 predictions, we're taking the one with the highest probability match, and we're returning the proficient. Right? So till here it's fairly straightforward. But what exactly is happening under upload underscore images? Briefly touched upon it in the previous class. Let us go in detail. Right here I've added comments also here, just to make sure that you guys understand what's happening here. In the case of upload underscore images, we go back to the flow that I showed you. What was the flow? The flow is about, let me also show you the video. Right? You are browsing for an image. Okay, you selected the image of a judge who is Kim. Okay, and you clicked on upload the image, and the image got uploaded. Image is preferable detection. You click on detect profession. This is where the training model was called and the prediction was being made, right? And now the application has identified that judge is a profession which has the maximum probability match, right? And then it's going to take some time. We got it is a judge. Now we are going to click the train model, select the right profession, and click on train the model. So what is going to happen now? That's what we're going to capture as part of this update method, because we're updating the training data with the new image that was just uploaded by the end user, right? How is that training happen? I say request dot method equal to post. So what it tells is it's a post request because I'm say click on submit, because if we go back to the train.html file here, go to templates, go to train.html file, right? You see that it is input type equal to submit. Now I clicked on train the model. That's where it is, right? I clicked on train the model. It's a submit. By submit, by default, you are posting the request to the server. Now it has taken the value of this profession variable, right? Because that's exactly what we're taking. Whatever is the value, right? Request.form profession will be captured and will be placed as part of this text. Right? This is a new variable that I'm creating, text, and that contains the actual profession that you have selected from the drop-down. Okay, and then what I'm doing here is I'm creating a variable called creds that contains the service account credentials that I've read from the JSON key file name. Right, so this is a service account that I've been using to upload the content, right? So this is the service account credentials. All the service account credentials are acquired, and drive underscore service equal to build. So basically what I'm doing is, as I told you, when I click on train the model, what is happening? When I click on train the model, what's happening is it is taking the folder, taking the image that was uploaded, right? So placing uploaded image placing upload image into the folder that matches the profession. If I uploaded a judge and then I selected the judge as the selected profession, right, it will place this image in that folder as judge, right? That's exactly what's going to happen. So drive underscore service is needed to connect to Google Drive, okay? And then what it is also doing here is this. I'm again creating a duplicate of this variable name equal to text. The reason for that is I want to make it more standard driven. And then I'm defining two variables, typed and message. Typed tells me that the folder that I'm looking for, now this is the task that we need to do. First things first, what I need to do, I need to find the folder ID, right, of the folder that matches the profession name. If I selected judge, right, I want to know what is the folder ID of the folder that has the profession as judge, right? Because only if I know the folder ID, I can place the new image in that folder, right? That's exactly what we are trying to see here. So that's the reason why I say the type, what are the types I'm looking at? I'm only looking at folders. Application/bnd.googleapps.folder tells you that the kind of folder that you're looking, the object that you're looking on Google Drive is not a standalone file. You're actually looking at a folder, right? And then what is that? So there is something called MSG. It's a parameter that I'm defining. MIME type equal to type. MIME type is nothing but folder, right? Equal to plus type means I'm concatenating this typed information, and name equal to name, which is nothing but the name of the profession. Why do I need all that? I am trying to get the folder ID here, right? Get the folder ID, the folder, right? So I use another method called drive underscore service dot files, right? I am getting the list of files, okay, that match this folder ID and name, and I'm executing that drive underscore service dot files, right? So in order to know more about drive underscore service, you can do that here. Drive underscore service dot files, right? It's an API, as you can see here. So this API, what it tells is it gets the metadata about a file. Right? So one second, let me also show you exactly where that is required. Google Cloud. So Drive REST API v2, right? This version 2 that we're going to use, right? And this is exactly what it does. It gets this file ID, upload type, this parents behavior information, everything directly using drive underscore service, right? It gets you the list of files that match the folder. Now you must be wondering, what if the drive underscore service that you're seeing here, right? It is returning the list of files, and from that I'm only concerned about the files metadata, right? I'm just getting the file details 0 ID. Basically, I just want the ID of that folder. I don't want anything else. I just want the ID of the folder that matches the name passed by me as a profession, right? Now you must be wondering, what if Google Drive, if the folder ID is hierarchical, in the sense, right? What if there is a parent-child relationship? Will that not make it complicated, right? Let us see how exactly the folder structure in Google Drive actually looks like, right? drive.google.com. If I just go to my organization ID here, right? Says something like this. Look at ident_prof. This is the folder, right? You see every folder, even though JSON is a folder that is inside the ident_prof folder, click on JSON, you see the folder ID is changing, right? There is no hierarchy. It's not as if there is one more folder here, one more folder ID here like this, right? And slash this, right? That's a huge advantage. Basically, what we're looking at is just that folder ID. Every folder has a separate folder ID, irrespective of whether it is inside a separate folder or not, right? Whether if it is a standalone folder or not, right? Now what we are doing here is, if you look at this code snippet, I am actually getting the folder ID, the file details, right? So basically, file details contains nothing but the IDs of all the files, all the matches, right? I'm only looking at the ID of the judge folder. I'm actually looking at just the judge ID, judge folder ID, right? That is exact. So this is exactly what I'm looking at, right? So if you see in the output here also, if I see in the output here, right, you see this is the, so when earlier we tried with mechanic, isn't it? This is the ID of the mechanic that we got, right? How do I get that? You can look at intermediate output for these things, or let me show you the intermediate output here itself, so that you understand better what's happening here. Right? First, let me print list files, right? And here, let me print file details. Okay, let me just execute all these code snippets here. So now it is running on the local machine. This time we'll upload a different image altogether. It'll take some time. My machine is occupied with memory, right? But observe what's happening here. Till here, right? We are, the whole point of these code snippets is that getting the folder ID of the folder whose name matched with the profession. That's what we are trying to get here. Get the folder ID of the folder whose name matched with the profession, right? Now you see this is up. Let me just upload an image. Let me go to pictures, and then let me upload the image of another mechanic, right? There is a image of this person called Mixon. I'll upload, right? Click on upload, and then I'm getting an internet server error. Right, because the reason for that is here in my local machine, I wrote pure coding, the code which is not really optimal. So what I did there is, I'm renaming every file to test.jpg, if you guys remember, right? And I forgot to delete it. That's what I'm going to do here is go to templates, go to test.jpg. So that's what you'll get to find internal server error whenever there is something wrong, right? Click on shift delete, right? Now I need to restart this particular code again. Click on this, and it's going to take some time. Coming to that. This was initially the frustrating part. So whenever, luckily for us, because we're outputting everything onto the Jupyter notebook, you will see why the find internal server error shows up here, right? Generally, I worked as WebLogic administrator. Whenever we see that there is a find internal server error, there is always something wrong on the application side. And that's when you generally get a 500 internal server error. Okay, so now we are just waiting for this console to start. It will take some time because, and this is also another reason. Now your customer must be wondering, why is my local machine so slow, right? That's the reason why generally your local machine is not just dedicated for running Flask applications, isn't it? I have all those browser windows opened up. I have all those other things running in the background, right? Ideally, that's the reason why you should be creating your own VM, right? Both in Google Cloud and also here. If you create your own virtual machine, what happens is you dedicate that virtual machine resources completely to the running of the program. Right now, it is so slow, popping up because I'm not creating a virtual machine. I'm just using the machine as it is. Right? I'll also share an article that talks about creating a virtual machine. Right? Now I'm uploading Mexen here. Okay, and now the image is getting uploaded. Right? Once the image is uploaded, it will say that image is prime for detection. Okay, so it will take some time to upload it. As I said, it is a bit slow. It's a bit on the slower side, right? And then as you can see in the output here, right, whether it is successful or not. Here itself will get an error. If there is something wrong, 200 is successful code basically. It says that everything is fine. If you see 200, you should be happy about that. Right, now it is uploaded. The upload is successful. As you can see here, I got a 200 code. That means the image has been successfully uploaded. Image is prepped up for detection. Right, now detect the profession. It is going to search for detect the profession. I can see the information here itself, whether it is working properly or not. Right, it will see what exactly is happening here. Right, it has uploaded and it said mechanic, which is also true, that lady is a mechanic. Right, now I click on train the model. Right, now what it will do, it will give me the drop down. I select mechanic, I click on training the model, and here I got an error, and the error is list underscore files is not defined. The reason for that here is I should use list file. Right, so even though your code has an error, that's the reason why you got this error. Right, I should have used just list underscore file. Okay, so that's the reason why I got this error. Now the painful aspect is this. Now that I need to make this code change, I need to again interrupt this and start this and run this. Right, that's another problem that you'll be looking at. Right, but what we can do is, instead of me uploading this file multiple times and showing you what exactly is happening, what you can do is just look at, you have this code, right? Look at the output of list underscore file and file underscore details. Okay, so file underscore details will contain the information of all the files which are in a particular folder, or all the folders that match a particular designation, the name here. And then because I'm only looking at one folder, because there are no multiple folders are not there, right? You'll get a list of files purely because your name, the name judge, what if you contain multiple folders with the same name? Right, you get the folder IDs of all those folders which match with the same name as judge. In our case, we have only one folder which has the name judge. Right, you'll get that list underscore file information here, and then file underscore details is nothing but all the folders. You are just looking at the first match. Right, in our case, we can just go with the first match because we know that there is only one folder with judge. Right, the first argument is ID, second argument is name. Right, so that's exactly how we got the folder ID. And then what we are doing is we are placing the upload image into the folder matching the profession. So here what I'm doing is, whatever is the file name that I've downloaded, which is test.jpg, that's the folder, that's the file I want to upload, right? But when it goes to that profession, if you guys see here, when if I go to judge, every image you see here is starting with judge-2, judge-3, judge-4, judge-5, right? Every image is starting with judge, right? So that's in order to maintain the same convention, what I've done here is this: file name equal to str np.random.randint. I'll tell you why I did that. File underscore metadata equal to name text. So I'm giving the metadata of the file that I'm uploading, right? What is the name I'm giving to that file? The profession name, right? Name, profession, judge, plus file underscore name, which is nothing but this number, this random number, which can be any number between 0 to 1 lakh, right? So name judge 2, 3, 4, 5, 6, something like that, plus .jpg. It's a JPG file. And then I'm saying parent. The parent of this file should be the folder ID, which is the folder ID that we got, right? So this is the most important line in the entire code snippet when it comes to we uploading a file, updating the training data, right? We are passing the text, the name, based on the profession, and we're making sure the same convention is followed, albeit we're giving a random number between 0 to 1 lakh, right? And then parents folder ID. Okay, now I define the file metadata. Now what I'm doing is I'm calling the media file upload method, and this will upload this file, right, which is nothing but test.jpg, because that's the file that we just uploaded, right? That's the reason we are creating the test.jpg file in the first place. We're creating a test.jpg file in the first place, right? So that once it gets created here, we're uploading this. So whatever file that we uploaded, right, be it Kim dot, be it a mechanic, be it my photo, be it somebody else's photo. Every time it will be renamed as test.jpg, it will be stored here, right? And we are sending that test.jpg file using media file upload, right? And then we're making sure that that file gets created. So we're saying this is the file that has to be uploaded. We define the metadata, and now we are giving the location of the file, right? Finally, this drive service.files.create list gets all the names of the metadata about the files that are present in the Google Drive. dot create, what it will do? It will create this file, right? The actual file with the name that you're given in the Google Drive folder. That's what it is doing, right? File underscore metadata, metadata about the image, media underscore body equal to media. This is actual image that we are uploading, right? Fields equal to ID. Have a ID field and execute, right? And that's when you get print file uploaded successfully, right? And the return render template, file upload.html being successful, that's exactly what you're going to get. So click on train model, right? You'll get image uploaded successfully to the training folder, right? Image uploaded successfully to the training folder. This is how you get the output. Okay, now this is the code part of it, right? Now this is exactly what we are going to run here. So if you see the same code that I just said, right? It's just that you have list underscore file, you're getting the folder ID, the exact same code, right? And I'm returning this template. Okay, so now what we'll be doing is we'll be deploying it. For deploying it, we get something called gcloud app deploy. Okay, so what this will do is this will deploy it on App Engine. I'm not creating a VM instance here, but ideally you should be creating a VM instance to make sure that it is production ready. But for now, my application is lightweight, right? So I just do gcloud app deploy, and then the moment I do gcloud app deploy, right? What you got is an error. Why are we getting this errors? Because it is not finding an app.yml file, as you can see. Is this particular app.yml file is required to deploy this directory as an App Engine application, right? And it also gives you the path where you can get more instructions, right? And then it doesn't see the home folder, right? That's the reason why, because the reason for that is I'm directly deploying from here. I should go to the folder which contains the requirements.txt file and app.yml file. Right? You should always run the command gcloud app deploy from that place. Right? So gcloud app deploy. Now we get application. The problem is the user seems to be disabled. Okay, so there, what happened? I'll tell you what happened here. So now you get this error when you already disabled the app, right? So let me just go to App Engine here. Right, your app is currently disabled because what I did was unnecessarily I'm paying money here, right? That's the reason I just disabled my app. Right, now what you can do here is enable in settings. Go to settings for App Engine, right? And here, as you can see here, the application is disabled, right? So that's what I'm doing here. I'm enabling application, right? So billing charges will incur. This is one of the problems with cloud, isn't it? If you are just build an application for testing it out, learning concepts, you still pay for it. And that's why I'm looking at making sure that I'm using the budget free trial credits in the best possible manner, right? And now I just enable the application. An application update operation is currently in progress, right? So this is how you need to deal with. So for example, in production environment, you need to also look at whether the application is enabled or disabled, and this is how you enable it. And the one thing that I noticed from Google Cloud is that even though it is Google Cloud, right, some of the operations are insanely slow. It will take a lot of time to get those applications up and running, which you will see today. Right? So as the application update is currently in progress, I'll also show you other things that you should be looking at. App Engine instances, right? So these are the instances that I already have created in the Asia region. Always create instances in the region, because ideally when you are deploying the app for the first time, it will ask you what are the instances, which are the instances that you want to use. Right? It will let you decide where do you want to create those instances. Do you want to create instances which are close to Mumbai, right? Or do you want to create instances which are close to Singapore? Or do you want to create instances outside outside Asia, for that matter? Where do you want to create those instances? Right? That's exactly what you're seeing here. And they're auto-scaled, right? What does auto scale mean? Auto scale means depending on the demand, that the RAM that is allocated for instance changes. Right? So this is a nice repository that tells you exactly what's happening. Right? Each application has a default service, right? The service that takes care of running an instance, right? And this is exactly how it works. Right? The app engine services behave just like microservices. The API request, mobile devices, internet administration type requests, backend processing, everything. Right? And then you can have multiple versions of your application. So people who are into software development, you can better relate to that. You can have multiple versions. You have a version that is already deployed, and you have a version that you are trying to make changes and work on. Right? So it is taking some time for getting this instance ready. Okay, and then you can also see the other comments. Important comment that is important is this. Right, so let me just go to the line. Gcloud app versions list grep-v serving. So what this does is it gives you the list of versions that you have deployed which are currently running. Right. So let us see the list. Every command that you run here, automatically you can start using gcloud app versions list. And as you can see here, this will output the list of commands, list of versions that are currently here. Right? So these are the versions which are in serving status. I think the instance is up now. Let me just deploy this. Automatically when you select it, when you just select all the content, it is automatically selected. Right? Now I do gcloud app deploy. Let us see what happens. Now the application has been re-enabled, right? And it tells you this is a descriptor file, app.yml file. And this is the source. At home, Sai Chirantej, environment. This is my target project. And this is the default service that I'm using. I can also create new services, as you can, if you guys remember, this is where I enable the service, right? App engine services. This is a default service, right? Right now, it is still in application. I'm about to start this, right? Start the deployment. That's the reason why you were getting this error. But this is the URL, which is mapped to your application. It's a nice thing, right? Because you got a decent looking URL that you can share with your friends, right? So now let me complete the start. This is a target URL, as you can see here. This is a target version, right? That is going to be deployed. And do you want to continue? Yes or no? I say yes. Okay. So now it will take some time, but let us closely follow what's happening here. It's trying to begin the deployment of service, building and pushing image for service. Image is nothing but what is operating system, what is the programming language that is being run, basically the entire stack, right? So the image the operating system I'm using here is Linux, and the version that programming language that I'm going to run here is Python, right? It's just building that OS, and it is going to take a lot of time, but understanding what's happening in the log messages is going to help us. It took me a lot of time to figure out what actually is going through here. It started the cloud build, the first build of the application. To see the logs in the cloud console, I can click on this part. Right? I can also see the logs directly here, but we'll monitor the logs here. Right? It says I'm copying, right? So there's so many things that are happening here. It is fetching the storage object. So by default, everything is in GS staging. Right? App engine default. So all the files that are there in the default folder, basically some metadata that is required, it is fetching that information, and then it is starting these steps. Right? It is pulling image. Right? It's pulling from GCP runtime Python, as I told you. Right? This image that contains the operating system and the language that you're trying to run. It's using that step, and it has downloaded that. It is verifying the cumulative sum, right? And it's also downloaded a newer image. Right? It's trying to just in this here. It is just trying to download the image that is best suited to carry out or deploy my application. Right? And in the logs, I just switch my account because by default it's taking my other account. Right? So once you come here, you just go to cloud build history. Right? As you can see here, these are the logs. Right? It's just wrapping all the lines, and you can even download the logs. The exact same output that you're seeing there, you can also see here. right? So it is pulling the latest code, it is making sure that the necessary downloads are complete, and it is trying to actually give you the final output. So it is going to take some time. It's going to take at least 5 to 10 minutes. Now you see the Python version, you see the step label Python version, it has taken Python 3.6. Why did it take Python 3.6? That's exactly what I mentioned in the app.yml file. And it's collecting all the packages that we mentioned in the requirements.txt. You see here collecting Keras from requirements.txt, collecting OpenCV from requirements.txt, right? It's collecting all the packages at this point of time while deployment, right? Protobuf, Markdown, collecting cache tools, right? And then it is storing all these statuses into these different folders, system folders, right? It says successfully built py drive gcloud.pyml, right? And it's also said installing collected packages. Now it is installing the package, collected the packages. Now it is installing in the App Engine environment for our application. Right? There are some warnings that come in. Don't worry about those warnings. Okay, and you can also see that these packages that you are installing, right? It will always ensure that it is getting the latest versions by default, because we didn't mention the exact version, right? We just gave Flask, we just said Python. If you want to control the versions, then give the exact version name that you're looking at. But by default, it automatically takes in the versions, latest version. Right? Now it is looking at multiple iterations, making sure that it is actually taking the right versions, right versions of the package or not. It is just trying to look at iteratively what are the different things that it has to do. Right? In the meanwhile, let me also show you another important concept when this is getting loaded. Cloud storage bucket. Right? By default, whatever files that you're uploading, the best practice would be to create a bucket like Eagle Eye 789, this is a bucket that I created, and then give it access to the service account. Right? So click on Eagle Eye 789, as you can see here, and this has all the bucket policies and access control lists. You can upload files here, you can upload folders. So this is the best practice if you are to upload files. Right? Upload the files to this bucket, and then make sure that it is public. If you have public access, then you get this output. Why am I doing that? Because why am I telling you that is because here what if you want to store all the files that you uploaded, right now I'm going to tell you how my code is actually going to work in Google Cloud, but in future if you want to further optimize this code, the best practice would be you just store all your uploaded files in a place, in a bucket, and then read from there. In my code we're not doing it, but in future if you want to further optimize this code, right, you upload all of them to a Google to a bucket and make sure that it has public access so that your service account can access the files in the bucket. Google is pretty strict with storage. That's the reason why I'm telling you this is the best practice that you can follow. Right? Now it is going to take some time. Now it is updating the service. Right? Now what is happening is it has put all these packages, everything. Now it is executing the code. Right? It is trying to update the service. And this will take some time. This may take several minutes, as it said, but this will take a lot of time, maybe another 5, 10, 15 minutes. Okay, so in the meantime, what we can also do is this, right? Let me also show you the other components of Google Cloud Platform that are important to us, right? APIs, right? What are the APIs? You can also use your own APIs here. Right, so like say these are the APIs that I was using. So I'm using the Stackdriver API. That's basically Stackdriver API. What it does is it just looks at where all the errors might come up. Right, it can also tell me where are the errors happening. Cloud Deployment Manager, right? So what are the errors and what exactly is the problem with that? Right, latency, network latency, how slow is the network, how quickly can it ramp up, right? And then also if you see here, so far we've seen the app engine, right? Compute engine is where you can create your own VMs. That's the difference between compute engine and app engine. App engine, you're just deploying the application, but what if you want to create a custom image? Right now you're just downloading the default image that is provided by Google, which is Linux operating system, and you're deploying your Python code. What if you want to create your own stack, right? That's when you use computing. I create micro VMs or large instances running Debian, Windows, or other standard images. Right? Let's you create your own instance. Right? L will be charged for the instance. Right? And you can just create the instance, or you can take the quick start. Take the quick start. What it tells you is here you can see how to create a Windows VM, how to import or migrate your workloads, right? Migrating VMs using Illustrator, right? And you can understand the pricing part of it. Right? So compute engine you need it. So for you to optimize this code, right now I'm showing you the basic cut, but to further optimize this code, what you can do is to speed up the process. But right now it is going to be slow because I'm just deploying it on the Google App Engine. In order to speed it up, you can create a virtual instance, and then that way it will be speed up. Right? You'll see in the demo how this is slow. Okay, and then you can also look at, so there's good documentation. The only thing is you need to go through a lot of documentation to understand all these things. That's the whole reason why in this video we're just focusing on the most relevant stuff. But one interesting thing that you might be really interested in is the AI platform. Right, if you just click on the AI platform, right, you can see different, you can deploy notebook instances. You can see how you can get started on this. This is the next thing that I'm trying to try out, right? So basically, the recent release the ML AI platform. Earlier, it used to be ML engine. And when I started building this project, it was ML engine. Now it has become AI platform. So this is the next thing that I'm planning to explore so that I can use this to deploy my model. Because right now, it is so slow if I directly deploy it in the app engine, right? But the problem with using Google's APIs, Google's ML engine is that, particularly APIs, is that those APIs might not serve your purpose. Say, for example, you're working in the legal domain, right? And you have data that is so pertinent, so related to your clients, right? If you use Google's NLP API, Google might not be able to understand the context in which your legal documents are present. Same as with the company data. Right? Google will be generalizing it based on, let us say, news articles, the words that are used there. Accordingly, it might give weightages. Whereas the stuff that you have, this legal stuff, which is stuff that is domain specific, Google might not be able to influence that, right? So that's the reason why we're going through all this pain. Also, using Google's API is a bit on the pricey side, right? So that's the reason why we're going with this particular pain, right? You might be asking, is Google App Engine, isn't that costly? This is also costly, right? You see the credits, the entire information amount that is allocated to you vanishing just like that, right? So that's the reason why, I mean, the better option would be to create the necessary infrastructure in your local machine itself, right? Create a web stack, create a using LAMP stack, you can create your own web server. Make your own laptop be the web server. That is also something that I gave a try, but then it was not really sustainable as such because of the fact that I use my laptop for every other purpose also. But generally, if you have an old laptop which you think has good RAM and good processing power, but which you are not using that much, what you can do is you can create a web server there and let that be the point. Deploy this Flask application there. You will not get all the support that Google App Engine provides, like logging, debugging, everything, but you can create it. For those people who are really interested in that, you can reach out to me and we can discuss as how you create your own web server. Right now, I'm using Google App Cloud, Google Cloud Engine, purely because I have all the content in a Google Collaboratory, and I also have all the input training data, everything in Google Drive. So it makes sense, right, to go for Google Cloud here. Otherwise, I could have used Amazon or Microsoft Azure if this was not the use case. If the data is directly residing in my local machine, I would have used them. But because of the ecosystem integration being easy, that's the way I'm going here. Saying that, Google has recently come up with Theanos that helps it to get integrated seamlessly with Azure and Microsoft and Amazon Cloud. And that is another option that you can explore. Right? But for our practical purposes, we are doing this part. Right? As you can see here, this takes a lot of time. Gone to it's not because we're not just running code and seeing the output, just like Python. We are so used to Python kind of corrupted us. We got the output really fast. But as you can see here, this is app deployment. So many things, so many interdependencies. It has to perform a variety of checks, whether any code has changed, if it has changed, what has changed. Accordingly, it has to deploy the application. So this will take some time. Okay, let us also see the logs here. So this is about the cloud bucket. Right? Other than that, we are not using anything else mainly here in for this particular project at least. Maybe for the advanced projects, you might be looking at Kubernetes engine where you're looking at multiple VMs, multiple applications getting deployed. Maybe you'll also be using BigQuery, Cloud Table, File Store, Firebase, right? File and also your own virtual cloud. All these things might come in future. But for now, we are not really using any of this. Another thing that you'll be interested in is monitoring, where you're looking at how much time it is taking for the application server to start up, what are those metrics, and how does it work. Yeah, this is a stack driver thing that I told you, right? So it will just tell me what is wrong with my code. Instead of you adding debug statements into the code and redeploying the application. What this does is stack driver by default, without you explicitly adding debugging statements, it itself will directly connect to the application code and will give you the output. That's the advantage of using this stack driver directly. Right? Another advantage is it will also help you. This is more powerful than any of the stuff that Microsoft Azure or Amazon Cloud provides. This particular capability helps me debug my application without me putting any extra debug functionalities in my code. If you see, my code doesn't contain anything about default debuggers, right? So I didn't have any debug code in my application, but I still be able to see the application. So now the updation is complete. So I think it took close to 8 minutes, right? And then it also shows that now if you see here, it has given me the log information. This is the log, right? So basically I just selected it and it will just wait for the new log entries. It will give me the log messages. This is the log message. Okay. Now, in order for me to see what exactly is deployed, so this is the log from the previous runs that I have run, right? Now I just click on Control C and I just go to the URL that was given here. What was the URL? This is, you can see here, right? Deployed service to HTTPS eagle-eye 238.408.appspot.com. Right? Let me go to this URL. Right. So now you get the details of what I was trying to do, right? So if I click on browse, now we see whatever we have deployed on our local machine, we deployed the exact same thing onto Google Cloud, right? Click on browse, and then I can select the image. Let us select the Mechanic 2 image. Click on upload your image, and it will say image is prepped up for detection. Right? Now I click on detect the profession, and this is where I see there is a lag. Right? So as you can, let us quickly see what's happening here. I found a lot of inconsistency here because sometimes it works, sometimes it doesn't. Because what's happening here is I'm not using Google Cloud Storage Bucket because there were some issues with that. So what I'm doing there is I'm just uploading this folder to this file image to the temp folder, and from the temp folder itself, I'm passing that image to the code, right? Because the code that I'm running here is actually getting run in a staging environment. So if you remember when logging first started, there was a staging environment at the start, right? Now it is trying to run it from that particular area. Now you see how the TensorFlow instructions are getting called. So what's happening in the backend, right? So as you can see, temp/mechanic-2. This is where the mechanic-2 image is, right? Now it has timed out by bad gateway, as I told you, right? There are still this can be optimized better, right? So I've already figured that out. The timeout issue will happen. So what I do is I again click on refresh. Right? These are some of the teething problems that are still, because deploying machine learning model without using a virtual instance, this is how it is going to be. Right? You need to try it multiple times and then it will work. In this, now it worked. Right? Got it. It's a mechanism. So that's it's a tried and tested. I know that the error is going to come first time when I'm deploying it. Second time I click on refresh, then it gives me the exact profession. Right? So this is how you deploy this model. This is how you deploy model to Google. This is what you wanted. Right? Now I click on train the model and it will tell me who exactly it is. And I click on mechanic and I click on training the model. Right? Now if you see here, you will see what is going to happen here. It gave me the output. right? And now we are looking at what exactly are the chances, whether it is posting to training folder or not, and that's exactly what happened here. Image upload successfully to the training folder, and we go to app. Right, that bad gateway timeout, I've been trying to fix it, but I'm unable to make any headway on that. So what I came to know that is that you need to create a VM instance to make sure that the allocation of resources is better, and also it is faster when it comes to executing that. But I didn't want to do all that, create all the VM instance stuff and everything, because already it is complicated, isn't it? Building a Flask application, deploying a machine learning model, and getting the results and everything is already complicated. I didn't want to further complicate it, at least for understanding purposes. I can just use the default VM, maybe just live with that issue that it might be timing out once in a while. Just click on refresh and it works. Right? So what we have seen in this video is whatever we have done in the previous recording, we have taken that code from our local machine and we deployed it to Google Cloud. Now this is the URL. So you just click on home, right? This is a URL that you can share with everybody. This is my end goal. When I first started on this project, the goal was, I've seen from previous batches, many of the students asking, how do I give a user interactive way to people to know the stuff that I've been doing? You've been working on a variety of projects, right? Both in Data Science Foundation and in the machine learning track, where you are trying to look at building linear regression models, naive-based models, right? But what if you want to share a URL with the recruit or your friend, right, to let them give user input? Because that way, it's all about data collection, isn't it? You want the data to be clean, perfect, in the context, right? So this is how you also get better data. That's like how I've shown you. And now what I'm doing, I'm asking the user himself to tag the profession of the person when he's uploading the image. I'm asking him to select the image and give the image, right? The profession of the person's image and the image. This is exactly, now the training data is going to be damn accurate. Why? Because it's the user himself who's going to give the training data. I don't need to, again, worry about getting data from different folders, right? It's the users who are creating this, giving me that output, right? As you can see here, right now in Iron Pro, under the train folder, we have this other folder, and right now there are no images here, but in future they're going to come and store and be stored here, right, in the other image, right? And it will have the name of the particular profession also, if you select other, right? And then if I go to judge folder, and I can look at all the new images that got uploaded, because their naming conventions would be random numbers in those digits, right? So I can, now what I'm getting is, I can start with a stupid model, and I can keep on improving that model with more and more data. That was my goal, if you look at it, when I first started upon this project, right? A model that can take feedback from the end user and improve. Right? This is what we have seen: creating a project, download the access key for service account, create the app.yml file, deploy the application in the cloud. This is what we have seen, right? But what was my original goal? The original goal is this: does machine learning fit the product goal or not? How does the product behave on machine learning? What are you comparing with? How quickly should product change? As a product manager, you think about these 4 questions. And then your approach is this, right? We built an image detection model. We wrote a Python code snippet that takes the input image from the end user and make the prediction about the profession of the person's image, create the necessary HTML files. We build a Flask application. We deploy the Flask application in Google App Engine, and we take feedback from the end user and predictions made by the model and retrain the model periodically by incorporating end user feedback on new images, right? So these are the things that are the most important parts. The whole goal of this particular idea of discussion is to get you guys to think at a product level, because I personally feel the world is in need of AI-powered products like this, which are important for you to not just build machine learning models that make predictions, but actually integrate those things back into the model that you are making. Right? So that's exactly what the goal of this particular discussion is. I hope you guys enjoyed what we discussed. This is a high-level approach. I'm also going to share the code. I'm going to upload this code into my GitHub account, and I'm going to give the GitHub account. So you will see this code in my GitHub account here, github.com/SaiChudantej. I'll soon upload this code, right? And then if you have any questions, any feedback, more than welcome to share it with me. And also be more than welcome to, if anybody is interested in further improving this and maybe integrate this to a mobile app, I'm not a mobile app developer, so I've not developed a mobile app, but you can also look at that. So you reach out to me if you're interested, and I can actually integrate this into a mobile app, so that from the camera of mobile phone itself, we can real-time detect the profession of the person just by looking at the mobile. That will be even cooler, isn't it? That's the future of this project. Awesome. Hope you guys enjoyed this. Until next time, this is Sai signing off. Bye.